let's look at this first example. Now, I'm going to do something a little weird with this example. With this first example, I'm going to think of chain rule with each individual part of this left-hand side. So this first one, I'm going to think of it as the mommy u squared, and then I would do the chain rule, derivative of the mommy, times the derivative of the baby, where the baby in this case is x. So the derivative of the baby would be 1. Or, let's write it like we did in the last video, dx dx. Now let's take this next one. So this would be negative 2u cubed. So I'm going to take the derivative of the mommy, so 3u squared, times the derivative of the baby, which in this case is y, so dy dx. And then the last one, change this to a 3u, so plus the derivative, this one doesn't even have a chain rule, so we would do plus 3, and then derivative of the baby, which would be dx dx. Now, I know that's a really weird way to think about this. So we have 2u times dx dx, then the derivative of this times the derivative of the baby, plus 3 times the derivative of x, equals the derivative of 6 is 0. The reason we're writing it so strange is for you to see that when I take the derivative of x, like we've seen at this point, I get dx dx, or 1. And then I can plug u back in, which for this first one was x. So when I take the derivative of x, I get 1. So I don't actually need to take chain rule derivative of the x, because it will always be dx dx, or 1, which will just go away. However, when I'm doing implicit differentiation and I take the derivative of y, that's dy dx, or y prime. That one does not just go away. Plus 3 dx dx is 1. So the reason we wrote it in this very strange way is to show you if you take the derivative of x, you get 1, which is something that we've known for a long time. The derivative of x is 1. But the derivative of y is dy dx, or y prime. So anytime you take that derivative of y, you need to add this little hook on y prime. When you're taking the derivative of x, your hook on is dx dx, or 1. So you don't really need that hook on. But if it's a y, you need that hook on of y. So if I simplify this further, I get 2x minus 6y squared y prime plus 3 equals 0. Now this says specifically find y prime. So what I need to do is now solve this whole equation for y prime. So the first thing I'm going to do is bring all of anything that does not have a y prime in it, I'm going to take to the other side. So then that side, all my y primes are on one side, everything else is on the other side. Now, I can just get rid of everything but the y prime. And now the y prime is by itself. And there's your derivative. It's very different than what we've been doing so far. It's a little strange, but hopefully with a little more practice, you'll get a little more used to this. In the next video, we'll do another practice problem.